Okay, so before we start using this model, what I want to do is explain a little better what I mean by low frequency, high frequency, and wave interference. So what we've got is a couple of wave patterns drawn up here. And in earthquake waves, they're the same as any other type of waves. We have the crest of the wave and we have the trough of the wave. The frequency of these waves are determined by the number of crests that pass any given point in 1 second. Okay? So here, since we have much wider waves and much taller waves, we're going to have a low frequency because we're only going to have 1 or 2 crests that pass the same point per second, where down here you can see that the crests are much closer together, so we're going to have a high frequency, relatively speaking, where a small earthquake is going to generate more crests per second than a large earthquake. Okay, so now what everybody needs to understand is that all buildings have a natural vibrational frequency. That natural vibrational frequency is the frequency at which they vibrate. If we have the frequency of earthquake waves match the frequency of a building, what we end up with is positive wave interference. Positive wave interference is when you have 2 sets of waves and the crests and the troughs line up. As that happens, these waves interact with each other and are amplified. That is, they're added together. So instead of having just shaking from the result of an earthquake wave, if that frequency of wave matches the frequency of the building is going to shake with the combined amplitude of both its frequency and the building's frequency. So now the question is, what size buildings do we need to be in for which types of earthquakes? This is a very important thing to consider when engineers are designing buildings, as to what type of frequencies they have and what frequencies different size earthquakes have. So what we're going to do in the next video is we're going to look at this model that shows us a tall building and one that we have a small building, and we're going to shake it to find out which size building would be more likely to get damaged in what size of earthquake. Unfortunately, I wasn't able to send one of these to everybody's lab kit, so you guys are just going to have to watch this video to get an idea how it works. And we're going to do that in the next shot.